Hello friends, myself Arnab Kundu. You are watching my channel Technical Arduino. This is another video on Arduino in Tinkercad. Okay, and today's topic is that how to control a servo motor using Arduino in Tinkercad. So go to the computer screen. Through Tinkercad web application, I will discuss today's topic step by step. So let's dive in. So friends, today's topic is that how to control a servo motor using Arduino in Tinkercad. So before we start our discussion or today's video, at first we should know what is servo motor. A servo motor is a specialized motor that can precisely control the linear or rotary motion of a mechanical system, right? Servo motors have three wires. One is power, another for ground, and another for the signal. The power wire is typically red and should be connected to 5 volt. The ground wire is typically black or brown and should be connected to ground, right? The signal pin is typically yellow or orange and should be connected to PWM pin, means pulse width modulation digital pin, right, on the board, means Arduino UNO R3 board, right? PWM pins are available on Arduino UNO R3 board, which are 3, 5, 6, 9, 10 and 11. So one of them we can select as our signal, right? Some of the core functions used in the sketch, means when we write the code for to control a servo motor, then we are using at first the hash include servo.h. This header file we need includes this servo library. We are using lots of function. Servo.h is concerned. This header file is concerned, right? Also you can create an servo object, like servo is a class and the object name, suppose we given here my servo, right? And also use attach and write these two different inbuilt function. In that way you can use my servo.attach and put the PWM pin as an argument, means attach the servo to a PWM pin, and another my servo.write and put some angle according to how we can rotate the servo motor arms, right? Either 0, 45, 90, 180, like that. Okay, so this is the picture of micro servo motor where have these three wires are there, and for red wire is concerned, it's a 5 volt should be connected with the Arduino board. The brown wire connect with the ground, and the control or the signal, the orange wire is connected with the PWM pin. Here we take the pin number 9. Okay, so go to the Tinkercad web application. I will write the code and also design the circuit, right? So I have already logged in within this Autodesk Tinkercad using my Google account. So at first we go to the create this option and choose circuits. Okay, and from there at first we choose our Arduino UNO, this board, and then we choose here micro servo motor. This is the servo motor is there. The three different wire we are using here. Rightmost signal we put the PWM digital pin, middlemost put the 5 volt, and leftmost put in the ground. Okay, so at first we take suppose the red wire, and this is the power, so we select this power and just go to the 5 volt. So this is our 5 volt from Arduino UNO board is concerned, so we just connect it. Okay, now take another wire, suppose black, which is the ground, so we choose from there, and suppose we choose the ground from there also. This is the ground. Okay, now the last wire, suppose we take here the green wire, and which should go the PWM pin. Suppose we take the PWM pin here, the pin number 9, right? So we just connect with that PWM pin 9. So this is a simple circuit. Rightmost signal where is go to the pin number 9, middlemost go to the 5 volt for the power, and the leftmost just go to the ground. So we already designed the circuit. Now just write the sketch or code for this circuit is concerned. So go to code, and from there just select the text, okay, and select continue. So now we write the code here. So at first we define the header file. We already know we need this header file to control the servo motor. So just write hash include, and the header file name is servo.h, okay, and then we define the PWM pin. So that's why we are using here macro. So just write has define, and then suppose we write here servo pin and put the pin number is 9, and we also take here the object of this servo class. So just write servo, and suppose we write here our object name is my servo, okay. Now we write the void setup, and here we define the attach this inbuilt function, okay. So just write my servo dot attach and put here the pin number whatever we initialize as a macro. So just write servo pin, which is actually the pin number 9, okay. This is only part is concerned about void setup. Now we write our void loop, which continuously rotate or continuously going on and on, right. So at first we write here the angle, means we write here my servo dot write, the object name is my servo dot write, and send some angle. Suppose at first we send the angle is 0, means 0 degree we are sending here, and then put some delay. Suppose it's in 1000 millisecond, means 1 second. Then again call my servo dot write and send suppose the angle 45, again put some delay and put the millisecond 1000, again call my servo dot write and put the angle suppose 90 degree, again put another delay function with argument 1000 millisecond, again call my servo dot write the 180 degree, okay, and at last also put some delay and it's also 1000. So this is a simple code we write here for to controlling the servo motor, okay. So now we just start simulation and just see the servo motor control according to our code. At first it go start from 0, then it go 45, then it go 90 degree, and then it go 180, means somehow the arms of the servo motor are rotates according to angle whatever we are provide within the right inbuilt function, right. So this is the one way we can control our servo motor, okay. Now we just stop the simulation and we want to put the another different code to controlling the servo motor. So in that case what we can do, just see how we can change the code. So we can change only in our void loop this part, and we are sweep our servo motor arms, right. So in that case we using here for loop, and then we initialize an integer int angle, suppose a variable name, and put the initial value is 0, okay, and it rotates up to less equal 180 degree, and now we just increment this angle value, so angle plus 1, okay. And what this for loop does, same way the my servo dot write and send the variable angle, okay, and after that we put some delay, and here we send only the delay is 15 millisecond, okay, and end this for. Again we open another for loop, just write int, now it go for the reverse, it start from 0 to 180, now it go from 180 to 0, okay. So that's why you put the angle value, initialized value is 180, and now it go angle greater equal 0, and then we write angle equal angle minus 1. So it will now decrease its value and up to when it go up to 0. Same way call my servo dot write and send same as angle this variable as its argument, and also put the delay 15 millisecond, then end this for and also in the loop. Okay, now we close this code and now start simulation. And now just see the servo motor sweep very smoothly. Why? Because we put some for loop between that and it just incremented to one value each and every iteration, right? That's why the sweep is like that, start from 0 angle to 180 and again come back from 180 to 0, right? So in that way we can control our servo motor also. I hope you have understood today's video how to control this servo motor using Arduino UNO board in Tinkercad web application. If you like this video, please like it, share it more and more. Those who are still not subscribed my channel, please subscribe it. Keep watching Technical Arduino for more videos. Also write in the comment section what type of video you want to watch. So today up to this. Thank you and bye bye.